welcome everyone. Thanks for joining us today. This event is brought to you by Datadog's Club, which is a community of people who love data. And we host weekly events. Today is one of such events. And if you want to find out about other events that we have that we planned, please go to the link in the description. Click on this and you will see all the events that we planned. We have actually two types of events. So today, on Tuesdays, we have webinars. So these are typically talks with presentations. And then on Fridays, we have more like less technical ones. We usually talk about like basically like live interview. So we don't have slides there. So check it out. And then click on this big button to subscribe to our channel, not to miss any new videos. And then join our Slack. A lot of interesting stuff is happening in the Slack. Do check it out. You can ask any question or help other folks with their questions. And during today's presentation, you can ask any question you want using the pinned link in the live chat. So just click on this link and ask any question, and then we will cover this question at the end after the presentation. So I think that's all from me, and the floor is yours now.
Awesome. Okay. Thanks so much, Alexei. I'm going to go ahead. Do you have a link to the Slido, or do you want to just read out the question?
I'll just read out, and maybe I'll just share my screen, and so you can read this as well.
Awesome. Okay, let me go ahead and present. Cool. So, hey everyone, my name is Aparna. My background, so I have a technical background from ECS from Berkeley. Previously worked on Uber's machine learning platform team, Michelangelo, where I built the model store and put a lot of models into production. And in that journey, sometimes things went well and sometimes we had hiccups. And a lot of those times when we had hiccups, we just didn't really have visibility into those models to understand how to troubleshoot, how to improve them, and how to fix them. So that's what kicked me off to found Arise, which is the leading platform in ML observability. And today I'll kind of walk through, in terms of an agenda, just kind of what is ML observability. You've probably heard about kind of the different, you've probably heard about, okay, you need to monitor, you need to go be able to look for drift. And so we'll kind of just start off with an overview of what is it. And then some of these key things that you might be hearing about, like drift, how do you check for performance? How do you check for data quality or explainability? We'll kind of walk through each of these different sections and talk about kind of what are some best practices for each of these. And as I go through this, feel free to just ask questions, want to make this as conversational as possible. Cool. So first off, I'll just kind of, I think, start off with, why do you need, what are the challenges that people have with productionalizing ML? And what are the common questions that they're trying to ask? So, we ask this to almost, every ML or data team out there. And the common kind of, line that they'll say is, taking a model from that research environment, whether that's in a Jupyter notebook, laptop of a data scientist, into an actual production environment is extremely hard. The questions that, and there's different stages of these as well. So typically what we see is kind of a data scientist might build a model on a Jupyter notebook. And in order for that model to actually make it into production, there's a lot of things that has to happen. Sometimes it might need to be rewritten into a completely different, language. Sometimes you have to handle things like, okay, well, this feature in my notebook, here's how I did all the processing. How do I do this in a scalable way in production? And really throughout this entire time, as you're trying to move this model from maybe a notebook into production, data scientist is typically asking, will this model work? Is it going to do what it's supposed to do in production? Or am I going to put it into production and the performance is going to drop off? That typical training serving skew. Once that model is actually in production, typically folks ask, is it working? Is it doing what it's supposed to be doing? If I'm measuring, different types of models, you're measuring different metrics. Maybe for, if you're doing ad optimization models, you're measuring for things like, AUC, for calibration. You're typically asking, whether there's been a lift in engagement from the users. And so typically what people ask there is really just, is it working? Are the metrics that I'm expecting to see, the lift that this model should give, actually happening? And if it's not, what's wrong with the model? Is it not working across the board? Is it not working in specific slices? Are there areas where my model is underperforming? Is that due to, a new sample of data coming? So really starting to get into the troubleshooting aspect of what's wrong with the model and why, so that I can actually go figure out how to improve it and fix the model. And drop in the chat if you can, does this resonate with you? Is this stuff that you see? Are there specific questions here that you ask maybe more than others?
You said it's okay to interrupt you and ask questions, right?
Yes.
Yeah, because there is a question in the chat is, can you please give an example of how data leakage can happen after the model has been finalized?
Yep. So that's a great question. So I'll give an example. So data leakage is really kind of, training the model on data or giving access to the model to data that you may not actually have at the moment, when it's actually in production and it's serving those predictions. You're training the model on information that it may have, that you're thinking it has, when it doesn't actually have it. And it's one of the things to actually check for before the model should be deployed in production is, what features have I used? Are these features actually ones that I'm expected to get in production? One example is, if you're expecting to, if you're checking, let's say, cancellation rate for a user, if they cancel once, maybe they're more likely to cancel again. The first time that a user in production, there's been no cancels before, the first time that they're maybe looking at, the option that's presented to them, and that they're deciding, okay, do I cancel or not? They have zero, the model has zero information at that point to know, okay, has there been any previous cancels, in order to actually predict, is this person more likely to cancel? Now, let's say this same, instance now becomes a part of your training data set. In your training data set, for example, for point one, before they've even canceled, if you add in, okay, this person cancels 4 times in the actual training data set, then you're leaking information that the model is actually getting trained on, that when they were in production, they didn't actually have that kind of information to actually make a decision on. And so it's really tracking the lineage of information that you're actually receiving in production, and making sure that the model, as it's being trained, is only getting access to that information as it would have appeared in production. And it's just one of those things to actually check for, to evaluate before it's deployed into the real world.
So basically here in this example, the model kind of can see in the future, right? So it can see the future cancellations, even though it's not supposed to. And in production, these future cancellations, well, in reality, we cannot go in the future, right? We cannot travel in the future. That's why you don't have this information.
Exactly. So it's, typically when you start noticing things like, oh, wow, performance was really good when I built the model, but I put it into production, it's not that good. One of the things that to commonly check for is things like, am I introducing future information when I actually built the model, so it has all that information and it performed well? Or, is this kind of just data being leaked that I shouldn't actually have had access to in my training data? Hopefully that answers your question. I'm going to jump now into kind of some of the common production challenges that we hear, and we're actually going to go into each of these in today's talk. But at a high level, kind of, commonly we get asked kind of, okay, what are some things that can go wrong with the model once it's deployed in production? What do you see? And these are kind of, I'd say some of the common things that we hear from folks around production challenges. Things like model and data drift. So, hey, I built my model using this data. And, models deployed into production, and I'm seeing vastly different data than what I actually built on. So an example of this can be, maybe I trained my model on consumer, spending patterns, older consumers, maybe above 50, I deploy my model into production. The business team launches new promos to get younger folks into the app. And now the age range of folks that my model is seeing in productions actually has drifted in the production environment. Performance degradation. So, I'm, let's say, a fraud model, and typically, I care about catching when my model's predicting fraud, or sorry, when my model is missing capturing fraud. So it says it's not fraud, but then in reality, it was a fraud transaction. It has a bigger cost to my business because I have to go repay the person that got, actually, funneled out of that money. I have to go take care of doing all the investigation. So let's say I'm seeing a lot more kind of false negatives where I say it's not fraud, but it's actually fraud. So the question is going to be, where are the segments of predictions where I'm not catching these fraud transactions? Is it from specific merchant IDs, specific transaction types? Like, where am I actually missing this? And so that's, really common production challenge we see. Model interpretability. If you make a decision like you don't want to give this person a job, or this transaction gets denied, why? Why did you actually make that decision? If you were wrong, especially, you need to be able to have the justification. Data quality issues. This one's probably one of the most common ones we see across the board, especially if you have, let's say, upstream data pipelines feeding into your model. Anything like I'm missing data for a key important feature, or a feature is now going out of range, or I'm sending in mismatched data types, are all things that end up having an impact on what type of data that your model actually sees and uses to make a prediction. And so capturing data quality issues is really key. Model readiness. How do I actually make sure that what I'm putting into production is better than or worse than what I'm actually expecting? So is this new model actually better than what I'm expecting? And then lastly, specific industries, we see a lot more, focus on fairness and bias. How do I make sure that my model is not acting discriminately towards certain segments of the population? And so these are common things that, from a production perspective, should have visibility into, should be monitoring, and then should have tools to actually go down and troubleshoot as you start to see issues. And so with that, I'll spend like maybe another 5 minutes on kind of how does observability fit into the stack, and then we'll just go deep dive into each of the pillars of observability. So right now, there's a new stack that's evolving. There's a stack that we had for software 1.0, where you had platforms like GitHub to store your code. You had CI/CD checks via Jenkins or Circle CI, Datadog to do production monitoring and observability. And similarly, there's a new stack that's evolving for machine learning. There's platforms like a feature store to actually handle more commonly used in real-time use cases, but to handle things like the processing of features. There's platforms like a model store. Think about this as kind of like the ML flows or weights and biases that actually track the different experiments or versions of your model, store the metadata information. The model is then typically served in production. And then there's kind of a new kind of, similar to a feature store, model store, call this more of like an inference or an evaluation store that actually logs all of the inferences that the model is making. So some of the online inferences or logs, as well as the offline records as well, so that you have them to compare. Hey, this is what the model is doing in production. What is it actually, how does that compare to what I'm actually expecting? So the evaluation store actually stores the inferences of the models, whether it's before the model's launched or once it's actually in production, and then provides tools to really do things like root cause where the model is not performing well, do really granular analysis of the model so that you can, automate decisions like, do I need to go retrain my model? If the model is not performing well, do I need to go immediately mitigate it and fall back to a naive version of the model? If there's any features that have issues, how do I go and automate the resolution process by integrating with things like a data quality, data observability platform or a feature store to actually fix the upstream data that's coming into the model. Any questions on this, or does this make sense?
It does make sense. There is a question, I think, for the previous slide about interpretability. I don't know if maybe we can cover it afterwards or now.
Okay, we're gonna have an interpretability section in the deck, so maybe we can talk about that there. But the rest of this talk, I'll mostly be jumping into kind of observability. How does it, deep dive into that? So we'll focus on kind of this part of the ML infra stack, but there's a lot of depth across all of these as well. So what is an evaluation store? How do you get observability through it? So an evaluation store really kind of tracks different data sets from a model. So it takes in not just the production data, but also training data sets, validation data sets. All of these data sets are logged inside of this central kind of store. And then what the platform actually, what it actually does is actually starts monitoring for things like drift, data quality issues, or performance degradations using a baseline. So here's what the performance of my model should have looked like. And here's what I'm actually seeing in production. So think about it as kind of, monitoring the model for key checks against baseline. And all of these checks not only have to run, in aggregate, so across, the average of all of your data, but also across specific slices. So if I only care about, let's say, in California or only in Berlin, looking at specific slices of data and calculating these metrics is kind of the you should be able to do that. And this is important because, and we'll get into this as I kind of start deep diving into each of these sections, but when issues occur, being able to root cause them is going to happen by actually drilling down. So not just looking at everything, but starting to drill down into where this is happening, why is this happening? If you can figure out, okay, only in California I'm getting some bad data, you can actually start creating a feedback loop if you can root cause it to actively improve data or inputs from a specific segment to improve the performance of your model. And one last point before I start jumping into drift is you'll see this kind of throughout the talk, but you might have people ask kind of, okay, you've been talking about observability. How is that different from monitoring? Monitoring versus observability, kind of what's the difference? And, the key thing kind of that, I think this isn't novel to machine learning. People do this in the data observability world. They do this in the software kind of infrastructure observability world. But monitoring is kind of like, you can think about it like the top of an iceberg. It's the red or green light. It tells you, okay, signals, hey, something's happening here. There's something going on. But it doesn't actually help you get to the root of the why. What's actually going on? Where is it actually, starting to fail? And so some of the best practices that, we already have from the DevOps world and the data world, like, here's my baseline, let's compare it against the baseline to see has something deviated. Or, here's a funnel, here's kind of a troubleshooting funnel to help me drill down to where it's actually happening. All of these are kind of best practices from the DevOps or data world. And those same practices are also important in machine learning so that you can actually root cause and fix issues, not just kind of know performance is down. What do I do about it? Cool. Alexi, any questions before I start hopping into each of these sections?
Yeah, there is one more question about pre-launch model validation. Is it something you're going to cover next, or?
We should probably talk about it now because I think I might briefly touch on it in some of these, but maybe we can tackle it now. What's the question?
So can you explain a bit more about the pre-launch model validation? That's the question. Like, what is
Okay,
that?
got it.
When we
Yep.
use it, how we do it?
Got it. Okay. So pre-launch model validation, you can think about it as, I'll give you an example. So before you actually deploy software into production, you run these things like, think about them like Circle CI, Jenkins, to actually check that the code is, meeting certain qualifications to even be checked into your code base or to even, be deployed into production. And so similarly, with models, it's almost like data scientist builds it, data scientist says, okay, things look great, and then it just goes into production. Like there's no, formalized way of actually, how do I validate not just, is the performance look good on this one test set that the data scientist has checked, but certain use cases or issues that we've seen in production before. If I know my model does really well on certain age range, but not on certain age range, maybe the validation of the model should include make sure that the performance is above a certain threshold across all age ranges. If I look at specific slices of data, tackling kind of where does the performance drop off? Does it meet the bare minimum requirement for certain segments? And if you have another version of your model that maybe overall performance isn't as good, but it does better on certain underperforming segments, maybe that's actually a better model to put into production because it's more durable or stable across different slices. And so, pre-launch model validation, you can think about it as, how do I automate some of these checks that you want to check before the model is even deployed into production in a sort of repeatable pattern so that as you're creating new versions of your model, they're going through these similar checks to evaluate that this is actually ready to be deployed. And if you remember in one of the kind of earlier slides, we were talking about, will the model work? If you have pre-launch model validation, this should ideally help you start tackling kind of how do I systematically check, is the model going to work? And do this in an automated way before it's deployed into production.
So basically, like in software, usually we have
Mhm.
these integration tests, right? And we are only allowed to deploy to production when these integration tests pass, right? We run
Yep.
staging or something like this.
Yeah.
So a similar concept applies to machine learning, right? So maybe we run some offline tests on some data sets,
Yeah.
right? And then we see, okay, like in all this data set, it works fine. In these parts of the data, in these subsets, it also works fine. And then, okay, now we can press this button and the model goes live, right?
Exactly. And you can think about it like, you know, different teams do different things. Actually, the banking world has a lot more rigorous validation check process. They do things like, if the world was going to be hit with a, infectious disease like COVID, you know, and this is the economic patterns that we see, how will this model adapt? And so, you can actually simulate conditions, simulate data based off of those conditions, and then check basically how durable is this model going to be once it's actually deployed in the real world. But there's a lot we can get into that. So I'm going to jump right now into kind of these four key areas that I wanted to cover about observability. So drift, we'll be talking about all the details about drift. How do you measure it? Why does it matter? How do you troubleshoot it? Um, Performance analysis. So not just aggregate metrics, but how do you actually surface up the worst performing slices? Data quality. So what kind of metrics or key things should I check for? And then explainability. What are some common ways to incorporate explainability into your workflow? Cool, but we'll kick off with drift right now. So I feel like if you've been in the machine learning world at this point, you've probably heard of drift. Um, and let's just kind of level set. So what is drift? Drift is measuring a change in distribution. I love this visual because it kind of shows, here's one distribution at one point in time, my reference. You can think about this maybe as your age range. So you have some people over here, which are, maybe young children. You have some people on this end, which are maybe the older individuals. Bulk of maybe the people that you're seeing maybe fall into this mid range over here. Let's say you're using age to calculate, I don't know, you know, should I market to someone like, what types of engagement am I going to see? And so this is kind of your reference distribution of different ages. And once you deploy into production, so over time, you're kind of tracking this distribution. You want to track, does this distribution of age actually remain similar to when you built your model, or has it actually shifted? And if it's shifted, maybe you're seeing more of a specific segment, or in this case, the distribution's completely moved to the right over here. You want to trigger and notify kind of, hey, the data that you're seeing in production is vastly different than the data that you actually used to build your model on. And all of these models, they do best on data that is similar to data that they were trained on. And so if you trained on a specific type of data and then you don't see that, you see it kind of different in production, your model is not going to perform as well. And so it's important, especially in kind of these evolving, growing businesses, new product lines, et cetera, as you're starting to scale up, where the data is constantly evolving. It's important to make sure you can check for drift so that your models actually stay relevant. And there's a lot of different kind of, one of the questions we get asked is, okay, so what's a good reference distribution? So, I want to set my purple distribution over here to be kind of my reference. What are some good common reference distributions that people use? I'd say the most common one that we see across the board is kind of the training data set. So here's the data that I built my model on, and has that data actually shifted from what I'm seeing in production? Next is kind of, there's this, initial model launch. Sometimes your training data set might not be good. And an example of this is in fraud use cases. Typically, kind of the training data set is very different from what you see in production. In production, it's kind of an imbalanced class problem. Maybe 1% of your transactions might be fraud, but not even. It's like 0.1% of your transactions are fraud. But when you train your model, you might have your training data set with 50% fraud transactions, the other 50% not fraud, so that your model can actually learn how to detect the fraud from the not fraud. And so they might use in some of these cases things like, okay, here's when the model initially launched. Now I'm seeing this is the ratio between fraud and not fraud transactions. And that's what I want to actually set as my reference distribution. So, we see people not using training in some scenarios. And typically that's when they'll use something like model launch or a validation data set. And then, other common ones that we see are kind of, if you want to do something like always keep a trailing window. So last 30 days, last week, compare that against what my model is actually seeing in production today. And then also live A/B, kind of if you're testing two different versions of the model and you want to see, am I giving fair traffic or similar traffic to one version versus another? So you can actually test kind of the distributions of both. Let's see, I want to pause here for a second. Any questions so far about drift that I should tackle right now?
No.
Cool. Okay, I'll keep going. So next question, next thing is kind of, okay, so let's say you've determined this is my reference distribution. So now how do I actually calculate something like drift? There's a lot of different metrics. I'll talk about probably the most common one that's used in finance across banks and fintechs. It's population stability index, or PSI. And what it's actually checking is really, you can think about kind of in this case, the orange distribution here is the reference distribution. The purple is kind of your actual distribution, what you're seeing in production. And let's just take a single example here. So for something like car, so this is a feature. The feature is, what's the purpose for a loan? So I can get a loan for a car, I can get a loan to tackle credit card debt, a house, a loan for a wedding. And so each of these are different values of a feature. And car is one of the values. In my reference data set, I expected about 10% of my volume to kind of fall into 10% of my volume to actually fall into car. And then when I actually deployed my model, I'm seeing, maybe 9% of the distribution, or 8%, sorry, fall into car. And so what you're actually checking is what's the percent of volume that's falling into one distribution, percent of volume that's falling into your, actual distribution from production, taking the difference, natural log, multiplying them to actually get the PSI. And this is for one category. And so you can then do this across all of the different categories to get one final value. And think about this as really just, one metric to look at, you know, is there significant movement between one distribution and another distribution? And there's a lot of different metrics to kind of calculate drift. PSI is kind of one of them. There's KL divergence, which is actually, PSI is derivable from KL divergence. This is actually symmetric. So I can swap A and B, get the same value. I can't do that with KL divergence. It's typically used when one distribution is maybe much smaller in sample numbers or has kind of a larger variance. Another metric that people use is Wasserstein distance or KL divergence, or Earth movers distance. And you can think about this as kind of, people call it Earth movers distance because you can think about each distribution as kind of like a pile of dirt. And I want to move this pile of dirt over to another pile. And I want to look at kind of, how much work did it actually take me to move one distribution over to another? And so you can actually calculate the work, which is the area under the curve, and that's kind of the calculated Wasserstein distance between these two distributions. And so the point of this is just, there's a lot of different ways of actually calculating, how does one distribution, what's the distance between one distribution and another? And they're all trying to effectively get at kind of, is the distribution shifting or changing? And where drift is useful is actually, calculating things like larger scale trends in the data that's not typically caught by data quality monitors. What I mean by that is, before the pandemic, we actually saw, if you look at things like social media usage or marketing from social media, it's typically kind of Twitter, Facebook, Instagram, or YouTube. And then over the pandemic, of course, we all saw kind of TikTok rise up. And so you're actually starting to see, you can think about this as kind of, drift will help you identify these trends in data, shifts in data over time. Typically, these are called slow bleed failures because, in machine learning, things, one key difference in the software world is that it doesn't just stop working, like hard stops. There's typically, has the data shifted? Is the data moving? Is that what's causing the model to perform poorly? And so drift is a useful metric to be able to catch those types of issues. But what it's not good for is anything that has to do at an individual prediction level. So because it's looking at the entire distribution as a whole, if you have a single prediction that's, an outlier, or maybe some, one prediction with bad data, it's not actually good at kind of tracking those types of metrics because it's looking at kind of the aggregate view of the distribution, not just an individual prediction at a time. So some places where it's useful, some places where it's actually not useful. And typically, so I'll kind of walk through a little bit here of when there is drift, typically what folks do is kind of, first check for things like, is first the model's kind of output, the predictions, are they drifting? If the predictions are drifting, are there any inputs that are actually causing my output of my model to actually drift? So an example of this is if you start to notice maybe more fraud transactions over a period of time, are there any inputs that have changed that would be causing my model to predict more fraud? Maybe I'm seeing, new merchant types that are causing my model to typically my model would consider those kind of, more likely to be fraud. Is it actually catching those? Has the charge amount do I have more folks maybe sending in larger and larger charge amounts and the model's flagging them as fraud? And so maybe starting with the model output fraud, digging into what inputs could have actually shifted, and then seeing how do I actually change the data, maybe through targeted upsampling, so that I can see improved performance from my model. Any questions on this so far? Does this make sense so far? Alexi, any questions for me?
It makes sense, and I don't see questions. I was curious about this moving piles of dirt, to be honest. So
Yeah.
that was quite interesting, but I didn't get the part like the like how exactly, so these tracks and how do they translate to the area under the curve? So
In this one over here.
yeah.
Oh,
So
got
let's
it.
say, yeah, we want to move this pile of dirt to the other pile,
Yeah.
and we want to use these tracks to move the dirt, right?
Yep. So you can think about it like this view is kind of over here. It's kind of like, at this point over here, I only have to move like this amount of dirt, right, over to this
Why?
distribution. If I'm just doing like just from point 0 to point 1, like just thinking about it like these, if I just think about these as different bins or areas, so maybe I'm first just starting with like, you think about it like my 1 feet of kind of area, like, so I'm going to scoop up all the dirt that's between 0 to 1, and it's a very small amount. Then I go from 1 to 2, it's like a larger area. Then 2 to 3, it's significantly larger. So each of these is kind of like if I'm filling up a truck, and this is just a way to visualize it, but think about it as kind of like if I'm filling up a truck with dirt from each of these different like segments or bins. So how much dirt is my truck actually carrying? And if I'm carrying kind of significant amount of dirt, maybe I'm using kind of a significant amount of dirt and I'm kind of shifting it over. That's kind of the segments that has deviated the most, where my truck's kind of carrying the most kind of dirt. But it's just a visual representation just to show kind of like if I want to move one, if you just think about it as like I want to move one pile of dirt over to another, how much work would that actually be? Like if the purple distribution actually started from here and you just have to shift this over a little bit, you don't have to do that much work. But if I'm actually going to have to move this entire thing over to here, then it would be a significant amount of work.
Why it's 7?
This is it's just kind of calculating kind of the sum of all of the, so this one's kind of 1, 2, and then if I add the sum of this with the sum of this is kind of 3,
Okay.
4, 4.5, so you can actually just think about it as that way.
Okay, thanks for clarification.
Yeah. Cool. Well, I will actually jump into performance right now. And again, these are all just different aspects of observability. So, drift is one way to actually check the input data, make sure that the input or output data is what you're expecting it to be. If you're able to collect the actuals, you can actually start calculating performance metrics. And so what are kind of actuals? So let's say you're I always give this example from maybe Uber. Let's say you're predicting the ETA of a ride. So you guys have all taken an Uber ride. Uber will give you some ETA. My ride will come in 5 minutes, 10 minutes. So let's say the model predicted 5 minutes, but then the ride actually comes in like 10 minutes. So the model was off by like 5 minutes there. That was kind of the error. And so in that case, the predictions actually the time. So the ride will get there in 5 minutes. And the ground truth is actually, it actually got there in 10 minutes. And so this is kind of the actual or the ground truth. And in these kind of, certain types of model use cases, you can make a prediction, you'll get back the actual relatively quickly. You can match them back up, and then you can start calculating, what was the error term? What's my average error across all my predictions? And you can start calculating performance, really. Performance of what did I predict versus what actually happened. And this is actually the happy case, right? So you make a prediction, like in the Uber world, I predict ETAs, I get back ETA really quickly, and I get back when the ride actually arrived, maybe, within an hour, and I can start calculating performance metrics. But there's a lot of use cases where, some models don't actually have these fast actuals. What I mean by that is model will make a prediction, and then you won't find out about the ground truth for maybe, months later. So a common use case in this is, if I'm going to do in the lending world, if I approve someone for kind of like a loan. So if I say this person, I've approved them for a loan, I make a prediction, and then later I want to be able to, figure out, okay, is the, is my model actually making the right calls on who to approve and who not to approve? But I don't get back for this specific transaction. Did someone actually default or not, or did they pay back the entire loan for maybe 2 months after I've made the prediction? So I have to sit there for 2 months, not having insight into kind of all of the predictions that I've made in the last two months. I don't know if they were accurate or not. And so it's just, there's a significant delay to be able to even calculate performance metrics for these types of models. And so it just makes, if you're trying to evaluate the performance of your model, you have to kind of be innovative. Think about what are proxy metrics. So, okay, maybe I don't get back the actual metric of did they pay it back or not within 2 months, but I get back signals like, are they late on their payments, etc. And can I use those as kind of some way to say, okay, they were late on the payment. That's more likely to indicate they're not going to pay back the loan. So some way before the 2 months to get back actuals. And sometimes we see an even more difficult case, which is you only get back actuals for certain types of transactions. What I mean by that is if I decide to approve someone for a loan, they accept the loan, then I can get back kind of stats on, did they default or did they not default? So we approved them, and then we can calculate how many of the people did we approve, were we accurate on, how many people were we not accurate on. But the people that we decided to deny, the transactions that we said, okay, I'm not going to give this person a loan, we don't have any metrics to look at kind of if we had given them a loan, would they have actually, not defaulted and paid it back? Or were we right and we denied someone that actually would have defaulted? And so what I mean by this is just you're getting back biased actuals. You're only getting back actuals for certain segment of predictions, not across every single prediction you made. You won't get back, an actual itself. And then there's some use cases where people will really never get back any actuals at all. What I mean by that is if you're measuring things like, we had someone we were talking to who works more in life insurance. They predict mortality rates. So when is someone going to die? And they make a prediction, okay, this person's going to pass away 30 years from now, 40 years from now. And they basically don't get back any way of confirming, is that actually right for the next 30, 40 years? And, the point is just that they can't get back any ground truth about the accuracy of their model. And so this is actually a really important slide because, you think about people saying things like you have to monitor the model's performance, you have to monitor, how well it's doing. But if you don't get back the ground truth, this is not actually possible for certain types of models. And so it's really important to know when you're actually building the model, how am I going to actually calculate some type of performance once it's deployed in production? How do I get any signal at all that it's doing what it's supposed to be doing? And whether you have to use proxy information or, in some cases, we have people who, they measure, other, like proxy data to get back any signal about their model. But it's important to track kind of, okay, I know I don't have these types of actuals in production, but here are proxies that'll give me similar metrics that I can use to kind of evaluate when this model is starting to degrade in the real world. And any questions on this so far, Alexi? Does this, I want to make sure.
This one.
Oh, sorry, say that again.
Yeah, I said not for this one. So I noticed that there is another question, but about drift. So let's talk about this a little later.
Okay, sure. So anyway, this is a key important point as you're kind of, people are talking about monitoring performance. You can't monitor it if you don't have actuals. And this is actually why a lot of people use drift. So if you fall into some of these use cases where you don't have actuals, then it makes sense for you to actually measure things like the drift of your model, which doesn't require any actuals. And now, okay, so I'm going to jump into the side. Let's assume you have the actuals. How do you actually troubleshoot or surface up where the model is not performing well? And this is actually if you take away anything from this entire talk, this would probably be the slide that I'd say is probably the most important. There's typically kind of, overall or kind of average accuracy across your entire model. And maybe that looks okay, looks great. But when the performance starts to decline, what you really care about is, what are the different slices or segments where my model is actually really not performing well. So maybe the accuracy of my model is doing great on people with high net worth. Looks great, starting to not do well on people with lower FICO scores. But, it's actually significantly poor on people that have recently defaulted, only 10% accurate. And so surfacing up kind of, and this is kind of the challenge with kind of observability, is kind of, how do you not just give kind of high level stats, but can you kind of peel back that onion and give kind of, what are the slices of data where the model is not performing well? So that as a user, if you want to go and improve the model, where do you start from? You want to start from kind of, what are the slices that aren't performing well? Is it because you don't have enough training data on people with recent defaults in your model? Is it because you don't have people with kind of lower FICO scores? That's why the model is not doing well. And so actually knowing kind of what are the slices that the model is not doing well is going to help figure out how to go improve the model over the course of its life. And typically what folks do with this is, how do you troubleshoot performance drops? What they do is, maybe first tackle some sort of monitoring metric. Maybe it's accuracy. So now I want to look at overall accuracy. Then you can look across different slices. So you can look at, prediction slices as well as feature slices. So what I mean by that is you can segment, people use things like lift charts, for instance, to segment their predictions into different deciles and look at across each of these different deciles, what's kind of my predictions, what's kind of my actuals, how close or far apart are they? And so if I can narrow into specific segment that's underperforming, then for that specific segment, what are kind of features that are correlated with the performance drop? What I mean by that is, if you have a feature like FICO range, are there certain segments where the model is really doing poor? Where the model is kind of red, accuracy is really, really low, compared to, segments where the model is actually doing really, really well. So think about it as kind of like a heat map kind of view. That's kind of how I like to visualize this, is reds where the model is really underperforming, yellows where the model is doing quite well. And you want to surface up kind of where are the slices doing really poorly, and is it because of undersampling or lack of training data that was used to kind of build this model. And if you want to go improve that slice, how do I actually go fix the data to go improve the performance of my model? Cool. Well, hopefully that was kind of a deep dive into performance. Let me know if you have any questions. Otherwise, I'm going to kind of start hopping through data quality and explainability because we only have 10 minutes or so left. Lexi, did you want to ask the drift question right now?
Yeah, I guess we can. So the question was about, so we talked, I think, a drift as a change in features, right? But there is also drift that can be change of predictions, right? And yeah, the question was like, what are the differences between these two? And yeah.
Yep. Great question. So, yep, drift can be used for model inputs or the actuals, even actually the actuals. So, if you're getting back the ground truth, you can actually calculate it on the actuals as well. And most of them kind of operate in kind of a similar way. You're kind of trying to look at all the different bins, compare it against a reference distribution to calculate kind of the metric itself. Um, the main thing I'd say is kind of, how should you approach it? So typically there's kind of, you can check for prediction drift, and then you can also check for feature drift. What some folks will do is, what some folks will do is maybe only monitor for the prediction drift, only get alerted when the model output is drifting. And then when they want to troubleshoot it, they'll go look across all of the inputs and see in this example over here, sorry, it's really small, but what I'm actually looking at is kind of, this is a fraud model. And I'm looking at kind of what transactions of the model say was fraud compared to not fraud. And as the model is kind of increasing in drift, I can actually see there's a big difference between my training data set and my production data set. And so when there is high drift, that's typically when I want to look at things like, for each, what's causing this? What are my features that may have, been drifting as well, that's causing my model to predict more fraud? And so if you have something like, you know, different merchant types or increases in charge amounts that might push the model to predict more fraud, then these are actually ways that, you can think about it as kind of helping you root cause what's actually causing the model output drift itself. But, similar metrics can be used at a high level, kind of similar metrics can be used to look at the output drift or the input drift. All of these, or the actuals as well. All of these, you need to pick a reference distribution and then compare that to kind of the shift in data.
Thank you.
Cool. All right, I'm going to jump into data quality issues. So I'll spend kind of a couple of minutes here just talking about how we see different kind of bad data being handled for models. And what I mean by this is this happens to everyone, right? Bad data comes through bugs in the data pipeline, maybe bugs from third-party vendors. But how do people typically handle bad data? You might have something like, again, let's just use age as kind of our, an input into the model. And sometimes age might be missing. So let's say you have kind of a NaN or a missing value coming in for some people. They didn't want to send in their age. So in this case, how would you handle it? Sometimes some people will just drop the bad prediction request. If they get a missing value for an important feature, they'll say, I don't want to make a prediction. So they'll just kind of, it won't make predictions for these two requests. In some cases, people will have some imputation. What I mean by that is they'll predict or set some default values for this age. So, okay, so it's a missing value. I'll just take the average across my entire training data set and put that as kind of the processed input for this model. And so, the age is missing. Now it's 50. I'm going to now call the model, make a prediction request. And each of these can have different consequences, right? So when you drop the prediction request, if I just kind of think about it as I just dropped it, then I wouldn't make a prediction for people who are missing age. And sometimes in business critical decisions, you can't actually do this. Or you'll just be giving a lot of kind of user level errors of kind of, hey, we couldn't make a prediction, I can't do this. In being kind of not as reliable in the service. If you're setting in kind of imputations, the processed input that you could have can create drift in your model, something like, let's say, age 50 as your default value. I think most people do things like set the default value for integers to be like 0. And if you start doing things like 0 or the maximum value, you might start seeing that some inputs start to drift over time. And so, you want to be cognizant of kind of your drift. and also not introducing things like data leakage if done improperly. The alternative is also you could do nothing, right? You can just leave the missing value to kind of come in. I actually like this approach a lot because if your service can handle it without throwing an error, because then when you're monitoring in your system, you can actually track kind of as the drift. Let's say you had the distribution, how many fell into kind of the missing values bucket. So how many nans did you actually have? And so these are just different ways of kind of how, if you're missing data, which is just one example of kind of, how bad data can be introduced, what are some different ways that people typically handle this? And there's a lot of different kind of, checks that folks do to kind of check for the data quality in their model. Things like missing data, out of range violations. So has a feature gone outside of its expected range? Cardinality. So has a cardinality for something like, let's say, state. In the US, there's 50 states. Suddenly I'm seeing, 100 different values for states. Capital California, lowercase California, my model seeing those as different Californias. And so how do I actually track things like the cardinality for discrete variables, type mismatch? This is another common one. I'm expecting a float, I'm seeing a string value. And so the point is, these are some common different data quality checks. And the right balance here is really just how do you set up kind of the alerts and checks so that, it's not too noisy, but it's still providing kind of useful information and alerting you that some inputs are, sending in bad data, and proactively capture them before they start to impact the model performance. So these are a little bit more proactive to help you get at kind of the bad data. Cool. There's like 3 minutes left. So I think what I'll do is try to do a high level overview of explainability, but I think Lexi, you have the deck, feel free to send it out. And this space is really rich. So there's a lot of depth I'm not going to be able to go through, but hopefully this gives everyone an intro. I think the most high level thing I can talk about for explainability is that when people talk about it, they say explainability is gonna, it's useful, but there's different use cases for explainability. There's the global kind of explainability, which is across all of your predictions globally, what were the most important features? What kind of drove the decisions? But when I'm troubleshooting, let's say I'm looking for a specific, if model performance is really bad in California, what were the most important features in California that were influencing the decision? And, did those most important features have things like drift or data quality issues that could be impacting the overall performance of my model? So think about it as kind of, cohort helps you kind of drive into the troubleshooting workflow of digging into kind of what's pulling my model in one direction, and what's actually pushing decisions in a specific, for some segment. You can also do this at an individual level. For one specific transaction, what was kind of the most important features? And so if I rejected someone for a loan or a hiring decision, why were they rejected? What did my model see or think was the most important feature that influenced that decision? And so each of these kind of, global, cohort, and individual, think about these as kind of they have different use cases in ML workflows. Typically the troubleshooting ones are kind of a little bit more on the cohort than the individual level. And so, in some more regulated industries, you might see a more push for kind of things like individual prediction level explainability to dig at kind of what was most important. I don't think I will be able to get into a lot of the rest of the deck, but at a high level, kind of, there's a lot of considerations as you're kind of setting up ML observability, things like fairness and bias, how to handle service metrics. We didn't even talk about things like unstructured data. So a lot of what we talked about is around tabular data, but images and NLP audio, kind of how to be able to tackle that. But hopefully, again, this gives you kind of a, high-level overview of ML observability to kind of get started on.
Yeah, thank you. And the question we had about interpretability was if sharp values are used, and you had one of the slides that I think answers that question. I think sharp and lime are the most popular approaches, right?
Yep.
And both of them are definitely used in production.
Yep. Yep.
Okay, I don't see other questions. Somebody says hello. Hello. We're actually wrapping up, so you're a bit late, Adela, sorry. But you can, of course, watch it in replay it. I just shared the slides with you, so if somebody wants to take a look at this last part that we couldn't cover, please take a look. And so how people can find you? So I saw your Twitter handle
You
there.
can find me on Twitter. Yeah, Twitter. Let me drop my Twitter on. I think this is just my handle's Aparna Dhinak. So feel free to link it, Alexi.
Yes, I will. So thanks a lot. Thanks for your presentation, and thanks everyone for watching and for asking questions, and have a great day.